Okay, so this is question 4 and 5. In question number 4, it says, let L be a linear transformation from Rn to Rm. What does it mean for L to be surjective or onto? And notice, let me just mention, these definitions also work in the slightly more abstract setting where L is just going from a linear, from a vector space V to a vector space W. Okay, so I've written it down already. I'm not going to write it down again. So what does it mean for L to be surjective? It means that LV equals W has at least one solution for all W in Rm. What does it mean for L to be injective? It means that LV equals W has at most one solution for all W in Rn. And what does it mean for L to be bijective? It means L is injective and surjective. Okay, and now I've given you, for question 5, I've given you a linear transformation given by its matrix, and so I'm asking you to determine whether it's injective, surjective, or bijective. Okay, so the way we do that is we row reduce, and for the theory, of course, see the videos. Or not the videos, come to lecture, or watch the lectures, or ask me. Okay, and so what we're going to do is row reduce this matrix. If there are free variables, it is not injective. If there is a row of zeros, it is not surjective. Similarly, or oppositely, or whatever, if there are no free variables, it is injective. If there is no row of zeros, it is surjective. Okay, so the first thing, when it's in row echelon form, all of that is when it's in row echelon form. So the first thing I'm going to do is subtract row 1 from row 2 and row 3. So the top row stays the same. Okay, the bottom row, or the second row, 1 minus 1 is 0, minus 1 minus 1 is minus 2, 1 minus 3 is minus 2, 1 minus 5 is minus 4. Now for the third row, 1 minus 1 is 0, 0 minus 1 is minus 1, 1 minus 3 is minus 2, 1 minus 5 is minus 4. Okay, and now I'm going to do the normal thing. I'm just going to divide row 2 by minus 2, so it's going to be 1, 1, 2. Okay, and now I'm going to multiply or divide row 3 by minus 1, so it's just 1, 2, 4. Okay, and now the next step, I'm going to subtract row 2 from row 3. And when I subtract row 2 from row 3, the top two rows stay the same. 0 minus 0 is 0, 1 minus 0 is 0, 2 minus 1 is 1, 4 minus 2 is 2. Okay. So this is in row echelon form. It has free variables. This fourth variable here, the fourth column is a non-pivot column. So there are free variables. So I can write there are free variables, so not injective. Is it surjective? There is no row of zeros. So surjective. So it is surjective. Is it bijective? It should just say, is L bijective? No, because it is not injective. Okay, so this is how you determine whether or not a transformation is injective or surjective. Row reduce the matrix of that transformation. Now, to answer a problem like this, you don't have to understand the theory behind, why the presence of free variables means it's not existent, or means it's not injective. However, you do need to understand that. To do this type of problem, you don't really need to understand it, but to have a complete, to get an A in the class, basically, you are going to need to understand that, at least.